Welcome to Unit 2, Video 3, Pressure. By the end of this video, you should be able to describe gas pressure. You should be able to differentiate between a barometer and a manometer and understand how each device works. You should be able to convert between pressure units. And you should be able to determine gas pressure using a manometer. So when we talk about pressure, we're going to be talking about gas pressure. Recall that we've already established that particles of matter are in constant, rapid, random motion. And gas particles in particular are even more random, disordered, and move even more quickly than particles of matter in other phases. When these particles, which are in constant motion, collide with the walls of their container, they exert a force. This force is pressure. Pressure is force over area. So again, as the gas particles collide with the walls of their container, they exert pressure. Atmospheric pressure is the pressure exerted by the air in the atmosphere. This is something we're going to be taking into account when we do a lot of labs this year. As you probably know, atmospheric pressure varies with elevation. If you go to a higher elevation, the atmospheric pressure is significantly lower due to the fact that you have literally less air above you. The mass of the air column above you is smaller. So as you can see by this diagram, as you go higher up in elevation, the number of gas particles decreases. Therefore, the atmospheric pressure is less. That's as opposed to closer to sea level, where you have more gas particles, which causes a higher atmospheric pressure. So how do we measure atmospheric pressure? Atmospheric pressure is measured using a device called a barometer. Here's a schematic diagram of how a barometer works. Notice we have a tube from which all the air has been removed. And then we have a dish containing liquid mercury. Mercury is a metal that is a liquid at room temperature. As the air pressure, the atmospheric pressure, pushes down on the mercury has nowhere to go but up the tube. The more the air pressure pushes down on the mercury, the higher up the tube the mercury will rise. This leads us to one of the most important pressure units, mmHg, or millimeters of mercury. This unit literally measures how many milliliters up the tube the mercury has risen. So that's one unit for pressure we'll be using this year. There are several others. These include torr, which is named for Torricelli, who did a lot of work with gases. And we also have ATMs, or atmospheres. This is probably the most common one we're going to use this year. And finally, we have pascals, also named for a famous scientist. What you definitely need to know is how to convert between these units. So this shows you the equivalences. 1 ATM, or 1 atmosphere, is equal to 760 millimeters of mercury. It's also equal to 760 torr, so we can use millimeters of mercury and torr interchangeably. And finally, that's equal to 101,325 pascals. You can see why we use ATMs most frequently. Let's look at an example for pressure conversion. Here we're asked to convert 735 torr to ATM. Just like before, we're going to start by writing the given, which in this case is 735 torr. Then we're going to select a conversion factor. Notice we have two options. We can use 760 torr over 1 ATM, or 1 ATM over 760 torr. Remember, 760 torr is equal to 1 ATM. So which one are we going to select? We want to select the one with the unit we're trying to cancel on the bottom. So we're going to go with 1 atm over 760 torr. Finally, we cancel our units. So torr will cancel with torr. And we solve. Here we get 0.967 atm. Does this answer make sense? Well, if 760 torr is 1 atm, then 735 torr should be slightly less than 1 atm. So yeah, that makes sense. Do I have a unit? Yep. Check, check. Have I rounded to the proper number of sig figs? Well, let's see. This number has 1, 2, 3 sig figs, and because these are defined quantities, they have infinite sig figs. So our answer should have 1, 2, 3 sig figs. Excellent. Now let's talk about how to measure gas pressure when the gas is in a closed container. First, it's important to note that if you leave a gas in an open container, it will escape that container and have a pressure equal to atmospheric pressure. Imagine blowing up a balloon but not tying off the end. All the gas would escape the balloon. The pressure of the gas that you blew into the balloon would then be equal to the atmospheric pressure. Imagine, on the other hand, that you blew up the balloon and closed it off. Now the pressure on the inside of the balloon is not the same as atmospheric pressure. If you wanted to measure this pressure, you'd need a device called a manometer. A manometer looks something like this and works similarly to a barometer. First, we have a closed container full of gas connected to a tube filled with mercury, just like in the barometer. Notice this end of the tube is open to the atmosphere. Now, it's important to realize this does not mean the gas is in an open container. The mercury is really dense, and it actually causes a seal to occur. So the gas is still in an open container, or a closed container, even though the tube is open to the atmosphere. So how does this work? Well, the gas in the container exerts pressure on the mercury in this direction, while the atmosphere exerts pressure on the mercury in this direction. When the mercury level exposed to the atmosphere is equal to the mercury level exposed to the gas, then we know that the pressure of the gas must be equal to the pressure of the atmosphere. They're both pushing equally on the mercury. Therefore, in this case, since we can see that atmospheric pressure is 1 atm, then we know the gas pressure must be 1 atm. Take this example, on the other hand. Here, we have a scenario where the gas in the closed container is pushing on the mercury harder than the atmosphere is pushing on the mercury. We know this because we can see that the mercury has risen further up the tube, meaning that the gas is pushing harder on the mercury than the atmosphere. In this case, the pressure of the gas, then, is greater than the pressure of the atmosphere. That brings us to the end of the pressure video. Let's quickly review our goals. First, we described gas pressure. We said that gas pressure is the force exerted by the particles of the gas when they collide with the walls of their container. Then we differentiated between a barometer, which is used to measure atmospheric pressure, and a manometer, which is used to measure gas pressure in a closed container. We also looked at how each device works. Then we learned how to convert between the pressure units, atmosphere, torr, mmHg, millimeters of mercury, and pascals. And finally, we learned how to determine gas pressure using a manometer. Remember, when the pressure of the gas is greater than the pressure of the atmosphere, you want to add the value of H. And when the pressure of the gas is less than the pressure of the atmosphere, you want to subtract the value of H from your atmospheric pressure.